So good morning, everybody, and I can see we have a really good attendance today. So welcome to the Desco Europe second in our series of weekly webinars. And today we'll be looking at the requirements of an ESD work surface. My name is Vaughan Callan. I'm your presenter. I'm the European Sales Manager, and I'll just ask Stephen Burns to introduce himself as he will be monitoring and answering the questions.
Hi everyone, yes, my name is Stephen Burns, Desco Europe Brand Manager. I've been with the company around 12 years and I'll be helping with answering your questions today. As you can see on the screen there are, depending on which version of GoToMeeting or webinar you're using, the question box might look slightly different, either like the left or the right. So just type your questions in there and we'll have 2 points during the webinar where we answer questions in the middle, and then at the end. We might not get to all of the questions, if it depends on time. We'll certainly respond to every single question by email, whether we answer it during the webinar or not. We'll get back to everybody by email if you ask a question. Thanks, Vaughan.
Okay, thanks, Stephen. I'll move on. So what is an ESD work surface? It's any surface where an exposed ESDS device is placed upon. ESDS is electrostatic discharge susceptible device, and as you can imagine, that is quite a mouthful. So probably moving forward, I will be just using the term of a sensitive device to cover ESDS. What is an ESD work surface? It's a surface to safely ground away static charges from conductors. Now that surface could be a workbench, it could be a cart, it could be shelving, it could be trays for holding and transporting product around. It could even be conductive foam, or even an ESD bag placed upon a work surface would then become an ESD work surface. So what does the IEC European standard say? And the one that we're referencing is the standard, excuse me, the standard we're referencing is 61340-2-3. There's two requirements for work surface grounding, and that is for product qualification and compliance verification. Now, product verification is for when specifying product, when you're looking to specify the product that you're going to install. And what we're looking for there, what the standard is looking for there is an RGP, which stands for resistance to ground point. And what we're looking for is a measurement of less than 1 × 10⁹ ohms. And also in product qualification, they're looking for RPP, which is resistance point to point, which again is looking for a resistance of less than 1 × 10⁹ ohms. And then for compliance verification, that's when the product is actually in place, and for ongoing testing, they're looking for a test of which they call RG, which is resistance to ground of less than 1 × 10⁹ ohms. I'll go through the differences between RGP, RPP, and RG a little later during the webinar. But you will notice there is no lower limit for ohms resistance for work surface matting. So it's, whilst we're looking for a resistance, the European standard is looking for a resistance less than 10⁹ ohms, it's recommended, although not mandatory, that the work surface should have a minimum resistance of greater than 1 × 10⁶ ohms. Now, let's look at work surface grounding. Now, all ESD work surfaces should be individually grounded, and the acceptable grounding points are, and generally is the building equipment ground, and the AC is the preferred ground. Now, the first thing here is, I'll just move my arrow, all work surfaces should be individually grounded. What we very often see is when people have a series of work mats is that what we call, they daisy chain them. And as you can see in this graphic here, so this mat is connected to this mat, which in turn is connected to this mat, excuse me, which is in turn attached to ground. Now, that is not an accepted means of grounding work surfaces, so do not daisy chain mats. There's a couple of reasons. Simply, one could be because you've got them all in series, that you know, at this end the resistance to ground might, because of the daisy chain and the link in the mats, could take it above the 1 × 10⁹ ohms. But also, and probably more importantly, for example, in this diagram here, if you can see, if you could imagine this mat here, we've got these 2 mats linked. If one of these ground points were to become disconnected, then that mat is therefore not connected at all to earth. So the accepted practice in the European standard is that all mats should be individually grounded back to the same grounding point, earthing point, as you can see in the lower diagram here. So what does an ESD work surface do? It eliminates charge generation on static sensitive devices. It dissipates charges from devices safely, and it also grounds isolated conductors such as tools and ESD packaging materials. There are additional benefits of ESD matting, and one is that they provide a non-slip surface. They can provide shock absorption, and depending on the type of matting that's used, gives varying degrees of cushioning and shock absorption. And we'll look at a couple of those as we go through this webinar. And you can also use ESD matting to create a lead-free ROHS area awareness. And you know, we even have the green matting, and some of that matting will even come with the lead-free branding on it. And it will also it can also be used, and is indeed used, for protection of workstation laminate tops. So I know we're very early into the webinar, but I'll just hand you back to Stephen to see if we've had any questions and provide some answers.
Thanks, Vaughan. Yeah, thank you everybody for your questions. As we mentioned, we won't have a chance to get through all of them during the webinar, but we will certainly get back to everybody by email. So first question here, are there different texture mats available? The answer to that is yes, and later on Vaughan is going to point us to the mat selection chart, which is a resource on our website, which gives an idea of the texture of our different matting products. But also we have, we're able to send you samples. On each of the item pages there is a sample request button, so you can request a sample to make sure the texture, or in fact any other specification of the matting meets with your requirements. So yes, different textures available, and happy to send samples so that you can validate that it's suitable for you. The next question is to do with the dissipative top surface. Why should the top surface why should the work surface be dissipative rather than highly conductive? I guess behind that question is, wouldn't it be better if it were conductive? And the reason is to protect the device from a charge device model event. If the surface is highly conductive, then the device, if it has a charge on it, when it's placed on the surface, will discharge very rapidly, and that can cause a charge device model event, very similar to if I have a charge on myself and I'm not grounded, and then I pick up a device, the damage to the device can be very similar. So the dissipative top surface means that the surface that the device comes into intimate contact with will remove the charge in a more controlled fashion without causing that damage. So that's the reason why a dissipative top surface is recommended rather than a highly conductive surface. There's a second question here about sampling. So just to reiterate, we're very happy to send out samples as you request to make sure that the matting meets your needs. Simply request that through the website. Vaughan, I'll hand back to you now. Please do keep your questions coming, and we'll answer some more at the end of the webinar.
Okay, thanks, Stephen. Some good early questions. I know we're only a short way into the webinar, and I'm sure there'll be more questions that come through for Stephen to answer as well as he answered those ones, because we become a little bit more technical as we go through, which might generate some further questions. So let's move on. So we'll look at some different types of ESD work surfaces, and the most common ESD work surface used is a two-layer rubber material with a dissipative top surface and a conductive underlayer. As you can see there, the dissipative top surface is blue, and the conductive underlayer is black conductive. As I say, the most common is two-layer rubber, and what we're using in this example today is Desco Europe Statfree T2 Plus material, which has a couple of key features. I mean, it has its oil resistant, its compound, and it also has ultraviolet UV stabilizer additives. What the stabilizer additives do is that they will prevent the material from discoloring and from drying out, which UV will do to those materials without the UV stabilizer additives in it. And when they discolor and dry out, that can also affect the electrical properties. So the Statfree T2 Plus material doesn't do that. Now, the best application for the Statfree T2, and indeed all two-layer rubber mattings, would be in standard electronics manufacturing areas, especially where chemicals and solder are used. Rubber is very durable and would be absolutely the best material to use, certainly where around chemicals and especially hand soldering, because of the high levels of heat that it can withstand. We also have some other materials. There are other materials available, and we'll look at two of ours, our Statfree Z2 and our Statfree O materials. Now, these are three-layer vinyls, and you can see that we have a top dissipative vinyl layer, and sandwiched in the middle is a conductive grid mesh, and then on the underside is a further cushioning dissipative bottom layer. And I was talking earlier on about shock absorption and the need for that, and this type of material is particularly good, for example, if someone is repairing disk drives, which have to be handled more carefully. Then you could use one of these type of materials that offer more cushioning. And you can see there's two materials there. Effectively, the construction is mirrors each other, but if we look here, on this bit here, and then where I was with my arrow down there, is the thickness of the material. And obviously, the thicker the material, the more dissipative vinyl cushioning layer we have on the bottom to give greater shock absorption. The best application for three-layer vinyls would be light duty manufacturing, where cushioning is needed, but I would hasten to say it would not be the best material for chemicals and solder. We also have another two-layer rubber matting, and I'll talk about our Statfree UC2 material here. The key features for this is designed to withstand abrasion, stretching and tearing. And we don't use any detectable levels of silicon or DOP. And once again, it has the UV stabilizer additives in it to stop discoloring, drying out, and obviously elongating the electrical properties of the material. Now, this particular material, the best application for this is in clean rooms, and is for use in clean rooms from class 100 to 1000. What we always say is that if you want to use this material in a clean room between class 100 and 1000, please request a sample from ourselves, which we will send to you, so you can then assess it for its acceptability into your individual clean room. Then there's another material, which is our EVA shelf lining. This is a conductive material. Now, this material, whilst being flexible, it's very strong and reasonably rigid, whilst maintaining flexibility. And this is an economy grade product then, where you don't necessarily want to go to the expense of one of the 2-layer rubbers or the vinyl materials for maybe putting onto as a shelf liner in a storage area. This particular product lends itself remarkably well to that type of application. And then we also do a disposable material, which is a fiberboard material, which you can use if you're using harsh chemicals, or if you want to give further protection to the bench matting that you have there. And as it says, this is a disposable material, very low cost. So, you know, it's ideal for those applications. And now just going back to something that I was referring to earlier on about our 2-layer matting with the UV stabilizers additives in the material to prevent discoloring and drying out. Well, this is a particular material. Now, this matting, this is the fiberboard that I was referring to here, the disposable material, but this is a rubber mat here. This is not one of our mats, but we've kept it into the graphic and referring to it in this webinar to show that a material without UV stabilizers will dry out. And when the material starts to dry out, this is what happens. This front edge here, and it's not so, you can't see it so well here, but along the back edge, that's where it's drying out and it's stretching and contracting and all sorts of things like that. And also here, again, you can just see on the front edge here where the discoloration is happening, and that's being caused by UV ultraviolet. So, you know, and that will also affect its electrical properties on there. So that's just a graphic way of showing you that what a mat without UV stabilizers happens. But we'll come back to what we're really talking about here is another type of work surface, which is our disposable material made of fiberboard. And as I say, best application is for harsh chemical environments. Now, something that's often overlooked, but actually foam can be classified as an ESD work surface. I mean, the key features of that is the closed cell cross-link structure, which is ideal for component stuffing, or, you know, as we say here, for, you know, as we can show here, for the insertion of pins into the foam to therefore put them all at the same potential, and therefore it gives them a certain amount of shock absorption. So foam can be classed as a work surface. So, you know, in this scenario here, you see you've got some conductive foam with some components on top there with the pins inserted into it. If that foam was then placed onto a grounded work surface, the foam would be grounded, but therefore it's also can be classed as an ESD work surface in that particular scenario. I think Stephen, well, I know Stephen in the earlier questions did mention our work surface mat selection chart, and I've shown you a few of Desco Europe's work surface matting. Here we have, this is on our website, is our work surface mat selection chart, and what it goes through the item description, the construction of the material, whether it's a vinyl, whether it's 2-layer, whether it's a 3-layer vinyl, and so on and so forth. It will even give you the resistance classification. Now, I'll be coming on to this in a minute, but that's important when specifying product, because you need to make sure that the product that you're thinking of procuring does meet the European standard, and as we say, which is a resistance of less than 1 times 10 to the 9 ohms. So, and there'll be a reference to manufacturer's specification that I'll come to in a little while. Now, to go back to the question that was asked of us earlier on that Stephen answered, that what type of surface finishes does our matting have? Well, you can see against excuse me, against every material here, it gives you the surface covering of that and what the top surface is like, and we also give best application and special features. So when thinking of procuring matting, this would be a really good place to start to see what we recommend is the best application and special features, and see if they fit with your requirements. But also, you know, speak to us, and we will give you best advice via email, telephone, any way that we can help you to make the right choice for yourselves. But this is available on the Desco Europe website to assist you in your selection. So now we'll look at the standards, and what we look at is qualification and compliance verification. Now, the standard calls for a qualification test, and that's detailed in IEC 61340-2-3. And for compliance verification, again, IEC 61340-2-3 and IEC TR 61340-5-2 2018. Wow, quite a mouthful. So going back to product qualification, the acceptable proofs of product qualification are the manufacturer's data sheet. And I'll hasten to add that all our products, as well as all our matting, has a very comprehensive manufacturer's data sheet. You can also use test reports from independent laboratories, and also your own internal test reports. So what we'll look at first of all is the requirements for product qualification. And as you remember, hopefully from the beginning of this presentation, there are two criteria that we look for in product qualification, and that was RGP, which is resistance to ground point, and RPP, which is resistance point to point. So in this first diagram in the top left, if you look at this arrow, if this arrow is really signifying a resistance meter, so what we have here is a 2.5 kilogram weight attached to the meter, and the other lead from the meter would be going to the groundable point on the mat, so resistance to ground point. And what you're looking for is the resistance between the 2.5 kilogram weight and the grounding point, and we're looking for that resistance to be less than 1 × 10⁹ ohms. And the other qualification test called out in the standards is resistance point to point. And once again, it's what we're looking for is to measure the resistance between these 2 points, these two 2.5 kilogram weighted probes attached to a meter, and we're looking for the resistance between these two probes to be once again less than 10⁹ ohms resistance. And you can see that the minimum distance to place the probes apart when conducting the RPP test is 250 millimeters. So then we go on to product verification. Now, the difference between this is in product specification, product specification is we're looking for a resistance to ground point, which is from a point on the mat to the grounding stud. For product verification, we're actually looking for resistance to ground, and this is a mandatory test. And you can see here that you'll need the test equipment needed to do that is a surface resistance test kit with two 2.5 kilogram probes, and we give you the test procedure can be found in this section of the European standard. But here's a graphic to show you the resistance to ground. So we have the 2.5 kilogram weight, and you can see the red lead is connected to the meter, and then the other lead from the meter, this black lead, is going from the meter directly into the ground, the AC grounding. So what we're looking for is the resistance to ground test, okay? And that is the mandatory test for product verification. And this graphic here just shows you, although not a mandatory test, we we always recommend that you still conduct a resistance point-to-point test, because it's a good way of tracking the surface resistance of a material. As materials get older, and certainly as they get dirty, which they will over time, the resistance level will increase, and this will, by keeping a record of the resistance point to point, will give you a good guide as to a cleaning program, which I will come on to in a short while. Now, there is no specified time scale for this mandatory testing of resistance to ground of work surfaces. What the standard calls for is periodic testing of work surfaces necessary to ensure they continue to meet specifications. Now, what we would recommend, and this is our recommendation because there is no specified retest time limit, what we would recommend is that they would certainly conduct this test on a monthly basis, and keep a record of that test, because you do need, as and when you do conduct your test, you do need to keep a record of that for further reference. Okay, so there is no specification as to frequency of testing in the European standard, but it's up to yourselves to determine how frequently you want to do that, but we would certainly say at least once a month. Now, instead of grounding and doing periodic testing, you could actually use a workstation monitor, which will ground the work surface as well as the operator. But what that doesn't do, it doesn't monitor the surface to resistance, which is the mandatory test. So you would still need to do that, but what a continuous monitor will do is will make sure that there is no interruption in actually in ground. So if you see here, these are the two grounding points here. If one of these became disconnected, so therefore you're not connected to ground, then the workstation monitor that you're using, you can see here the light is showing green, which would be good. If the ground became disconnected, then that would turn red and give you an audible alarm. Certainly, the compatible work surfaces that work with continuous monitors that we supply would include our 2-layer rubber materials, our 2-layer vinyl materials, and certainly our 3-layer vinyls. It is important to note that not all materials that you can buy from various sources will work with continuous monitors. It really does depend on the amount of carbon that is in the conductive layer as to whether you can get a good connection and a good reading for continuous monitor. So just if you're considering buying another material and you're using continuous monitors, make sure that you do test it to make sure that it will work with any continuous monitor that you have. So I did say a little while ago about cleaning. It's very important that you have a cleaning program, and certainly the resistance point to point will help you to determine the frequency of your cleaning program. So if you're regularly testing the resistance point to point, you will see, and you're keeping a record of that, you'll see the resistance creeping up over time as the material wears and as it gets dirty, and dirt is an insulator. As you see that creeping up, that would be the time to clean and then retest. It's important that you only use approved work surface cleaners, because general household cleaners that you can buy in your supermarkets and grocery stores have a high silicone content in them, and silicone is an insulator. Now, I might be preempting a question that someone would have asked, may well have asked Stephen, which we'll come to in a little while, but we are being asked frequently, certainly during these times, about cleaning work surfaces with alcohol-based cleaners, because of the cleanliness requirements around COVID and operator safety. Our recommendation is that if you need to do that, that you would use an alcohol-infused wipe. to wipe the surface rather than using an alcohol infused spray, because the spray will leave a lot of residue on the surface. Now, the alcohol would act as a drying agent once again, so that would, whilst it would undoubtedly clean the surface, it will dry out in time. So at this moment in, our recommendation is for COVID cleanliness is that you would use a alcohol infused wipe to clean the surface, and then give it a further clean using the ESD surface and mat cleaner to ensure that the electrical properties are not compromised. But the short answer is you can use an ESD cleaner. Continued use will shorten the working life and maybe affect the properties of the mat. So used in conjunction with an ESD mat cleaner, that's what you should be doing at this time. So now I'll hand back to Stephen to see if any other questions have come in, and we'll do our best to answer them. Over to you, Stephen.
Thanks, Vaughan. Yeah, we've had a number of questions come in the second half. We'll spend a little bit more time on questions at the end of the webinar now. Actually, Vaughan, that question did come up about alcohol, so thank you for covering it.
I thought it might do. I mean, you know how many phone calls and email questions we've had on that since the outbreak of coronavirus. So I figured I'd just address it because it's an ongoing topic for us, isn't it?
Yeah, and it's just that balancing act, isn't it, between the hygiene aspect, which is obviously very important, and protecting the lifespan of the mat. So, before these times, we would have just said alcohol cleaners are an absolute no-no. But now we recognise that there are two priorities at play, and so we just have to reiterate that point, that after taking care of the hygiene aspect with your alcohol wipes, make sure you protect the mat with Restore Cleaner. So I thought we'd come to that one first, since we just talked about it, and reiterate that point. There's a whole span of questions, so sorry if these don't seem to follow any particular order. There was a question about heavy assemblies, that maybe a cushioning surface would be good, but actually it's even too heavy to move around. Do we have a solution for that? And we haven't mentioned it in the PowerPoint, but we do have groundable ESD turntables, a couple of options at different price points that are on our website. So the person that asked that question will email you back with the links to those. And if anybody else is interested in groundable ESD turntables that are a compliant work surface, just ping us an email and we'll get those details to you. And you can find it on our website. Just search turntable. Very good question here about why would you choose an ESD mat compared to a bench with an installed, let's say, a laminate work surface. There are certainly benefits to a laminate work surface. You have an integrated solution. They're very hard wearing. The drawbacks are, here are some of the drawbacks. I think a matting material is easier to work on. A laminate material, the products will skid around a lot and can be quite difficult to work with. Certainly, ESD matting is easier and cheaper to replace. If you have a laminate bench and it does wear out over time, replacing that laminate is not a simple exercise and is quite costly. And the real benefit is that you don't need to buy a bench with an integrated ESD laminate. With ESD matting, you can turn any surface into an ESD work surface. So you can specify any bench you need with the other requirements that you have, perhaps shelves or a lighting rig or something like that, and you can turn that bench, and perhaps that bench comes from a supplier who isn't in the ESD business, and actually asking them to specify it with an ESD laminate is not very practical, or they won't offer that solution. Well, you can buy that bench that meets your other requirements and then add an ESD bench mat, and turn that bench into an ESD work surface. So those are a few of the
That's a great question,
mats.
Stephen. And the other thing I would go back to the first point you made is that it really is the operator comfort. Now, if you had two operators side by side, one working on maybe doing some hand soldering on a printed circuit board on a laminate top, and one on a top with ESD matting added to it, I can guarantee you that the one with the matting added to it would be the much preferred surface to work upon for the operator, because
Definitely.
of it's just so much easier to work on, because it does have the non-slip properties. It does offer some cushioning as well. So that is always a very big consideration for the operators.
Absolutely. There's a question here about the technical difference between a 3-layer and a 2-layer mat, and why would you choose one over the other? Let me say right at the start that all of our 3-layer constructions are vinyl products, so they would not be suitable in an application such as soldering, where you need heat or chemical resistance. If that's what you're doing, then you absolutely need a rubber solution to give you that heat and chemical protection. But the benefits of a 3-layer material is that both the top and the bottom side are dissipative. So remember, right back to the start, we had that question about why don't you want a conductive work surface to protect against fast discharge and charge device model damage. Well, a 3-layer material has 2 dissipative outer surfaces, so it's reversible. That expands the lifetime. The conductive layer is buried in the middle, can't come into intimate contact with the product. So it's a reversible mat in that sense. The other benefit of having the conductive layer buried in the center, so a 2-layer mat, the conductive layer is at the bottom, well, that means it can come into contact with various other paths to ground. So you could end up with unintended paths to ground rather than simply the grounding point that you have attached and connected away to earth. With the conductive layer in a 3-layer mat buried in the center, only your intended grounding point is the route to ground. That is important when you're in rooms where there's high voltage machinery that could send signals back up other unintended routes to ground, and that could then come onto your work surface. So that's another reason for 3-layer materials, and they also are particularly good with continuous monitors because that conductive mesh in the center is highly conductive, much more so than the conductive layer of a 2-layer mat. They're ideal for use with continuous monitors. But just to go right back to what I said at the start, if you're in a soldering application where you need heat and chemical resistance, then vinyl materials are to be avoided. They won't withstand those conditions. As we said before, we'll email out these answers to the people that have asked the questions to put that down in writing for you. This next question goes right back to what we saw at the start, which was using an ESD bag as a work surface. The question says, I was under the impression that only the inside of an ESD bag protects devices. The external side is a plastic, which is an insulator, and we should avoid having devices near insulators. That's a very good question. First thing to say is that not all insulators pose a danger to devices. It's only charging insulators that are a problem. Non-charging insulators, non-tribocharging materials, whether they can be grounded or not, don't present a danger to ESD sensitive products. They only cause a problem if they can be charged, and the material used in our bags is a non-charging material, so there's no need to keep a device away from that. The other thing to say is that our bags have a dissipative coating on the outside, and so actually would provide a path to ground if placed on an ESD work surface. If you place our bags on the work surface, that dissipative coating would provide a path to ground, and so if you placed a device on top of it, it would be grounded. Now, of course, I don't think it was intended in our slide earlier on to suggest that this is a long-term solution for a work surface. It's just simply to say that it would compare, for example, having a piece of paper on your work surface and placing a device on that. The device would not be grounded, whereas if you place a bag on a work surface and the device on that, the device would be grounded.
Yeah, indeed, we're not advocating using shielding bags or ESD safe bags for a work surface. What we're really alluding to there is that we see it all the time, and you must, if you are doing that, which we don't advocate, but if you're doing that, then that bag must have a resistance to ground of less than 1 × 10⁹ ohms. Okay, so therefore you would need to make sure that it's the right type of bag, that it's on an ESD grounded mat, and then if you're going to do that, then you should test from the surface of that bag to the grounding point to make sure that it falls within the resistance to ground as specified in the European standard. So it's not something that we advocate, and we don't sell bags as a work surface, but we alluded to it because we see it all the time, and we're just making the point that if you do that, then the resistance to ground still must be below 1 × 10⁹ ohms.
Next question here. I think we'll make this our last question. We're coming up to 45 minutes, so
Sure.
I think we'll pause after this one. But it's a great question about maintenance of work surfaces. Should I clean my work surface before I test it? I think we want to answer this in 2 ways. The first is to say that work surfaces absolutely need to be maintained as a matter of course. They should be cleaned regularly. But there are a couple of risks with cleaning right before testing. The first risk is that it can lead to a false positive if you've literally just cleaned the mat and then you perform the test. If the mat is still damp from the cleaner, it could actually be the cleaner that is carrying the mat test rather than the mat itself. So it's the cleaner that's passing the test, not the mat. And the other thing is that it doesn't give an indication of the normal conditions in which devices are handled. So the object of the exercise, the purpose of performing the periodic test is not to pass the test, but to see the conditions in which devices are normally handled. Actually, we're kind of fooling ourselves by cleaning the cleaning the mat just before we perform the test. We need to test the mat as it's being used. So during the course of the normal day, performing a test and seeing what the situation is. You want to know the truth rather than fabricating a scenario where you know you'll get a pass. I think that's a really good question there on performing tests, and the purpose of the test is not to pass the test necessarily, it's to be sure that your product is protected. Vaughan, back to you. That's
okay.
Well, actually, let me just finish by saying there are a number of questions we haven't answered. As we've said a couple of times, we will get back to everybody by email for those unanswered questions.
Okay, that's great. Thanks, Stephen. Yeah, I can see that we've had a lot of great questions, and rest assured we will answer every question that we've received. Just to reiterate, we've been referencing during this webinar the IEC standard, and you can see as a link on the screen there where you're able to buy the relevant standards for your own reference. And obviously, there's a whole host of information that's available on the Desco Europe website, which I would encourage you to use. So we showed you the mat selection chart, but whilst we're talking of work surfaces, every single product does have a very comprehensive technical bulletin that goes along with it to help you determine what's the right material for you to use. And just to really on behalf of myself and Stephen, to thank you for joining today's webinar. Any questions that you think of after we close today, please send them through. My contact details are on the screen, and we will be sending you a copy of this presentation that we've used today for future reference. And just to remind you, these are a weekly webinar, and I would urge you to sign up for next week's webinar, which is a very interesting one, as we'll be talking about ionization, which is maybe one of the least understood aspects of ESD control, and we'll be talking through ionization, how it works, the products, and how they could be of use to yourself in your manufacturing. So finally, as I say, on behalf of myself and Stephen, thank you very much for your time, and look forward to speaking to you again at next week's webinar. Thank you very much.